Yeah, so we need to finish up this tutorial because we had started looking at the predicted concepts for IGCSE Cambridge Physics Paper 4. So we have worked out part 1, we have worked out part 2, and this becomes the final part of this prediction. So I'll take you straight to that section where we are supposed to pick from. And if you have not watched part 1, part 2, and part 3, this is the time you need to check in the description. I've added the links, will take you straight to those particular parts. And if you are new to Proflan YouTube channel, consider subscribing so that when I'm going to upload more tutorials for more other subjects, you'll be notified. So let's go straight. Let's go straight and look at which is the other section that we were supposed to talk about. And here I need to mention that we had talked about electromagnetic induction. We had talked about electricity questions. We had talked about how to solve a question to do with transformers, how transformer works. So if you have not watched that part, indeed you really missed a lot. Make sure you check in the link that I've added in this particular video down there so that you can be able to get started. Question like this to do with potential dividers, we really discussed on how to work out. That was done in part 3. So let's go straight and try to figure out how to work out question to do with radioactivity. Here we are told that carbon 14, remember the number at the top is the mass number or the nucleon number, and the number below here, like 6 here, is representing the proton number or the atomic number, which is the number of protons. We are told that carbon 14 is a radioactive isotope. You need to understand, what do we mean by the term isotope? Isotopes are atoms of the same element which have the same atomic number or same number of protons, but different number of neutrons. Explain how atom of carbon 14 differs from the atom of carbon 12. We need to understand that they have the same proton number, but they have different number of neutrons. So you can say carbon 14 has 2 more neutrons than carbon 12. So atom of carbon 14 has 2 more neutrons, and so that means it's going to be more heavier than the other one. Describe how the amount of carbon 14 in the dead organism decreases with time. We were told the half-life is 5,700 years. So meaning after every 5,700 years, the remaining carbon 14 atom decreases by a half. So what's half-life? If you are asked what's half-life, what are you going to say? Half-life is the time taken for the activity of a radioactive substance to decrease by a half. And in a short while, we are going also to look at how do you find half-life from the graph, because those are the possible questions that you may be asked. So for radioactivity, you need to understand that. And we're told that the sum of wood, remember initially it was having a ratio of 1 to 1. So carbon 14 and carbon 12 were in a ratio of 1 to 1. After some years, the ratio becomes 1:4. So meaning it has decreased by carbon has reduced by a quarter. So how many half-lives has it undergone? After one half-life, it becomes a half the original. After another half-life, the half now becomes half, which becomes for a quarter. So which means that we have this quarter is corresponding to 2 half-lives. And we know one half-life is 5,700 years. So which means that the total duration since the decay began is going to be 2 times 5,700 years. And that becomes 11,400 years ago. Explain why the short half-life is suitable for this use. Radioactive substances or isotopes are used for different purposes. Diagnosis, for treatment of some ailments, we have what we call radioactive tracers. Radioactive tracers have to be they must have a short half-life. So if they have a short half-life, it means that they can disappear from the body. If they have a short half-life, they can disappear, or their effect can decrease within a short period of time from the body. So when they have a small half-life, a short half-life, then they can be used as stressors in medicine. And then they have a short half-life, so they don't stay in the body for long. If you're given carbon-14, then you are supposed to draw the model of that. So remember, neutrons are usually inside the nucleus and protons, and the electrons are orbiting around. So you shall have the neutrons and the protons inside the nucleus, and then we shall have the 6 electrons around. And remember, the number of electrons is equal to the number of protons. Moving further, describe how the composition of a neutral atom of carbon-14 differ from the composition of neutral of nitrogen-14. And nitrogen-14 has one more proton than carbon-14, even though they are having the same nucleon number in that case. Carbon-14 decays by beta emission. We are supposed to state what does beta emission represent. These are fast-moving electrons. Describe the change that takes place when carbon-14 emits a beta particle. We know that beta is an electron. Yes, it has a mass number of 0 and a proton number of -1. So meaning the neutron number inside the nucleus is going to be transformed into a proton and an electron. So describe the change that takes place carbon-14 as the beta particle is emitted. So the neutron is transformed into a proton. Half-life of carbon-14 is 5,700 years. A very old object is made of wood containing 1.2 atoms of carbon-14. When manufactured, it contained 9.6 times 10 to the power 11 atoms. But now it has 1.2. So we are supposed to determine when was it manufactured. So it means that we need to go to the original, which is 9.6 times 10 to the power 11. We decrease by 1/2, it becomes 4.8. Decrease that by 1/2, it becomes 2.4. Decrease that by 1/2, it becomes 1.2. So we start counting how many half-lives have taken place since it was manufactured until the current radiation that we are being, the current atoms that we are having. So we have 3 half-lives. So we take 5700 times 3, and that becomes 17,100 years. So that is how you can be able to use half-life to determine when a quantity was manufactured. We are told only one isotope of gold occur naturally on Earth, and then state what this indicates about the nuclear structure of all naturally occurring atom of gold on Earth. This indicates that all atoms have the same protons and the same neutrons. If they were having different, it would mean that they are going to exist in different isotopes. So determine the number of protons. So how do we approach that? We are told there are several artificial produced isotopes of gold. Gold 198 is an artificial isotope. It's used in medicine, in scientific research. Gold 198 decays by giving beta emission to a stable isotope of mercury. Determine the number of protons, number of neutrons in the nucleus of isotope of mercury. So in this case here, it was gold. Now it has become mercury. So what is the transformation? It was 198. It has to remain 198 because the mass number of an electron is 0. But 79, this has to be 80, so that 80 plus -1 becomes 79. So the number of protons in this case is 80, and the number of neutrons remains to be, number of neutrons is 118. How do you get that? You take 198 minus the number of protons so that you can be able to get the number of neutrons, because atomic number is equal to the number of protons, which is represented by the number on the subscript. neutron number, nucleon number, or mass number is protons plus neutrons. So I believe you will remember that during your exam. A sample of gold 198 is placed near a radiation detector in a research laboratory. The rate is recorded at the same time every 32 days. The results are used to plot a graph here. You are supposed to determine the background radiation. Background radiation, you are supposed to check where it flattens. You read the value here, which is 20 becquerel counts, yeah, the count rate per minute. Remember also the unit for radioactive decay is in becquerel. So maybe if you are asked that, you'll be able to answer that. Determine the half-life of gold 198. So first, you need to come and check what's reading here. The reading here is 390. Then we have to correct that count by subtracting the background radiation or the background count. So we subtract that, and then now half-life will be that corrected count divided by 2. Then you come and check where do we have 185. 185 is at this point. Then you will read the value down here, which is approximately 3.2 days. 3.2 days. So in the event you are supposed to answer a question to do with radioactivity, this is how you approach some of the question. Let me also mention a possible question that can be asked here. You can also be told to, let me just return this mic so that we can be able to continue. You can also be asked to state sources of background radiation. Sources of background radiation include cosmic rays from space, rocks and buildings, and also we can talk of plants because they contain carbon, right? Argon, radon, and argon gas also can contribute. Now let's move to space physics. Under space physics, we are told that a Milky Way is one of many billion of galaxies. A collection of billion of galaxies forms what? Milky Way is one of the many billion of galaxies we have, and each galaxy contains billions of stars. A collection of stars is called a galaxy, right? And stable stars transfer energy into space by emitting electromagnetic radiation from their surface. Describe what happens to the core of a stable star to release energy. In the core of a stable star, hydrogen nuclei fuse. Fusion reactions are the one that result to the production of energy for stars. Yeah, so in a stable star, there is fusion of hydrogen and hydrogen that leads to the formation of helium. So the fusion process is the one that results to the production of energy from stars. That's what you need to know. Also, describe how the light observed from the galaxy differ from the light that is emitted. Remember, the galaxy is moving away, so the observed wavelength is larger or longer than the emitted one because of the redshift. So you need to understand that also. State the code that astronomers use to determine the speed of a galaxy. That's the change in wavelength. And also you need to understand Hubble's law. And Hubble's formula is given here. H is equals to the speed of a galaxy divided by the time, rather divided by the distance between the astronomer and the galaxy. And if we work it out, we are going to get the distance being 5.9 times 10 raised to the power 24 meters. So you need to understand Hubble's constant is 2.2 times 10 raised to the power 18. And using this, we can also determine the age of the universe. I believe you may be asked questions from calculating the age of the universe. Anytime you are asked a question like that, remember age of the universe is 1 over Hubble's constant, which is 1 over 2.2 times 10 raised to the power negative 18. If you work it out, you're going to get 4.5 times 10 raised power 17 seconds. But here we are supposed to work out the age of the universe in years. So you're going to say this time in seconds divided by 3.3 times 365 days times 24 hours times 3,600. So anytime you're going to be asked question from space physics, you remember that. Something I need also to mention that you may be asked as far as the May June exam is concerned is the concept of orbit of comets, orbit of planets, and orbit of satellites, i.e. the moon. You need to understand the differences. The difference of the orbit of a comet and that of a planet is that the orbit of a comet is elongated, very much stretched, right? But the orbit of a comet is, of course, elliptical. But for that of a planet is elliptical, yes, but that of a comet is quite elongated, quite stretched. And if you have a challenge answering space physics question, I've added a link of the video I prepared of possible questions that can be tested. I picked many questions from past papers and I put them together as one video for space physics, where in that video I've discussed how you can be able to calculate orbital speed, how you can be able to answer question to do with phases of the moon, different aspect of space physics. Can you check the link in the description so that you can be able to watch that video, and also you can be able to download the PDF of that answers that I wrote there. So just check below. And if you're new to Proflan YouTube channel, consider subscribing so that when I'm going to upload more tutorials, you'll be notified. See you in the next tutorial. All the best in your coming exam May June. We shall also be testing possible practicals questions that will be asked in this coming May June Cambridge physics. See you in the next video.